So let's go after that. Same procedure. We look at the data. We choose two trials to compare such that the concentration of H2 changes. Now I'm going to choose trials 2 and 3 to compare because that changes. And then if you look at the concentrations of nitrogen monoxide for 2 and 3, that doesn't change. Now since we know X, I don't care what the concentration of nitrogen monoxide is because it just goes into the math. But it does make it easier if you can choose two trials such that nitrogen monoxide doesn't change, because then it cancels out. Okay, left side of the equation. Take the rates. And like before, I'm going to choose trial 3 rate over trial 2 rate because that's going to give me a number that's 1 or larger. And same idea, I'm leaving the units out of this part of it just for simplification purposes. Now the right side of the rate laws. So we have the information for trial 3. We divide that by the information for trial 2. Now we have one equation, but we have two unknowns, K and Y. But remember the reason why we're doing this. We don't know the rate constant. So whatever it is, it's canceling out. This, well, that just cancels. So let's make some more room. Let's keep working on Y. We'll focus on the left side first. So I divide that out. I get 1.9. Look at the right side. Oh, let's remove the part that canceled. So I have the numerator raised to the y, the denominator raised to the y. Well, I can collect terms. So it's the whole thing raised to the y. And this allows me to focus on what's inside the parentheses. So I divide that out. That's a 2. So we have 1.9 equals 2 to the y. So what is the numerical value for y? Now in my classes, I don't do fractional orders. So what's y close to? 1. 2 to the first power is 2, which is very close to 1.9. You can have fractional orders. I'm just not doing them. You gotta walk before you run. So where are we on our rate law there up towards the top? Well, we now know the value of y. So now we have our rate law. Rate is equal to K times the concentration of nitrogen monoxide squared times the concentration of H2. So that's the first part of it.